Here's a compound inequality that we have to solve with interval notation. Remember, when you're working on inequalities, you reverse the inequality sign if you multiply or divide both sides of an inequality by a negative number. So let's solve the following compound inequality. 1/2 minus x over 12 is less than or equal to 7 over 12, and 3 minus x over 5 is less than 5 minus x over 4. What values of x make this sentence true and that sentence true? Write the solution in interval notation and graph the solution. So I already took the first step that in the individual inequalities, I'd like to get rid of the fractions right away. So common denominator of 12, common denominator of 4 times 5 is 20. That'll allow me to not look at these fractions. I multiply 12 times 1/2. That's equal to 6. 12 times x over 12. That's equal to x. Don't forget the minus sign in between. 12 times 7 over 12. Multiply by 12, divide by 12, you just have 7. So already I can solve this for x. I could subtract 6 from both sides to make this 1, and then divide both sides by minus 1. I can also add x to both sides and subtract 7 from both sides. Well, let's subtract 6 from both sides and divide both sides by minus 1. Practicing the reversing of the inequality when I divide both sides by minus 1. I could say at this step that I'm dividing both sides by minus 1 or multiplying both sides by minus 1. But either way, I have to reverse the inequality. So this side is solved. Now on this side, I have 20 times 3 minus 20 times x over 5. 20 times 3 is 60. And 20 times x over 5, multiplied by 20, divided by 5 is 4. Don't forget the minus sign in between. Over here, 20 times 5. Subtract 20 times x over 4. 20 times 5 is 100. And 20 times x over 4, multiplied by 20, divided by 4. The net result is you're multiplying x by 5. And the minus sign is there. I could simplify this by adding 5x to both sides and subtracting 60 from both sides. And right away, that gives me an x is less than 40. Notice when I added 5x to both sides, this became a positive 1x. Subtract 60, this becomes 100 minus 60 is 40. So there's nothing left to solve or simplify here. So I have x is greater than or equal to minus 1, and x is less than 40. Both of these things have to be true for me to have an answer. If I have a number bigger than 40, it might make this sentence true, but it won't make this sentence true. If I have a number less than minus 1, it might make this sentence true, but it won't make this sentence true. I have to make both of these sentences true. In a picture, I could graph the numbers greater than or equal to minus 1 like this. And the numbers strictly less than 40 like this. A hard bracket and a round bracket. And then the numbers that belong to both answers will be bigger than or equal to minus 1 and less than, strictly less than 40. So the graph and I'm not trying to be careful with my scale. This is one time I'm not too worried about scale. I just want to know the location of the answers. I could also write this as -1 all the way up to plus infinity, intersected with everything from -infinity all the way up to 40, but not including 40. This interval notation says the same thing as this graph.